So i-input nyo lang yung buong equation na yan, ship solve, then that's it. Okay, next is the Manning's formula. So usually, ang ginagamit natin for pipes ay yung Darcy-Weisbach, and the third formula, which is the ano yung third formula? Hazen-Williams. So usually Manning's, although it can be used for pipes also, but normally Manning's is used for open channels. No? So Manning's formula, we compute for the velocity using this formula. Okay, 1 over n here is the Manning's n, and again, this dependent on the roughness of the conduit. So for example, kapag PVC yung pipe, there's a corresponding value for n. Kapag GI yung pipe, there's a corresponding value of n. And then it's equal to times yung R raised to 2/3 S raised to 1/2. S here is the slope of the energy grade line. So to compute for the head loss no, for a certain length of the pipe. So we know that the head loss is the difference in elevation between the if we put yung piezometers ito, piezometers, and we try to plot the energy grade line. So due to losses of energy, nagkakaroon ng loss of pressure ito, and then the difference in elevation now between the energy total energy at each point, that's our head loss due to friction. If that is the case, using this formula, we will arrive with this formula that is that the detailed derivation would be in your modules. So that will be equal to the head loss in terms of discharge is equal to 10.29 n squared LQ squared over D raised to 16 thirds. This is for the SI. Derive ito using the SI system. So ganun. That's how we compute for the head loss. So review lang natin the head loss. For example, ito yung pipe natin. Maglagay tayo ng dalawang piezometers between 2 points, certain distance. Okay, the energy grade line would look like this because of frictional losses, energy loss due to friction. No? So kung wala sanang frictional losses, magkapantay itong dalawa. But because of frictional losses, mas mababa itong second point. Okay, so the difference in elevation between the energies between these in these 2 points is equal to the loss of energy due to friction. Okay, and with that we can solve or derive a formula for head loss in terms of the discharge in the system. Okay, so that's Manning's formula. Again, the Manning's n is given in your modules. That is dependent on the material of the pipe. Yan. Ang nakalagay dyan sa module ninyo ay meron siyang minimum and maximum, no? Because of several experiments, ito yung range ng values, no, ng Manning's n. So you can use either the minimum, maximum, or in between values. Okay. And then the last would be the Hazen-Williams. Hazen-Williams formula. Okay. So using the Hazen-Williams formula, the discharge is equal to, haba naman nito. I think I have missed writing the number 7. So given this derived value or formula for discharge, and using the same principle we've used in Manning's formula, where the difference in elevation between the points is equal to the head loss, okay, we can also derive a formula for to solve for the major loss or frictional losses in the SI system, we have 10.67 L Q raised to 1.85 over C1. I'm sorry, this should be C sub 1. That is 1.5 D raised to 4.87. So medyo yan. May memorize na may mga decimal. Anyway, online naman, open notes naman later on. Okay, so C1, C sub 1. So yung C sub 1 is also dependent on the material of the pipe or the conduit, no? So pag concrete yung pipe or GI yung pipe, there's corresponding value for C1. Ayan. So that's how we compute for the head loss or frictional loss using Hazen-Williams formula. This is Manning's, and I have presented also the commonly used one, that is the Darcy-Weisbach formula. Now for minor losses, H sub m for minor loss, it is always expressed in terms of the velocity head. Okay, that is K times V squared all over 2G. So K here depends on the particular reason why there's a minor loss. Like for example, pag merong change in velocity, may sudden contraction or sudden enlargement or something like that, then there's a corresponding K for that. No, I think I have also put that in your modules. Ayan, so meron dun sa module ninyo, nilagay ko yung values ng K for each case. No? Kapag may sudden enlargement, sudden contraction, may bend, or may reducer, na-reduce yung cross-section, then there's a change in terms of velocity. There's corresponding value of K there. So, i-multiply lang natin yan sa velocity head. That would be the minor loss or minor loss. Okay, so that's it. Doon na yung mga principles, concepts na kailangan nating intindihin, and we will try to apply those concepts, principles later on to solve for the problems, no? Yung problems na nasa module natin. Okay, so that's it. See you sa next video where we will be solving the problems in your modules.